The Earth is getting hotter every day. Along with this, extreme weather events are occurring more frequently. Each year in Vietnam, powerful storms and prolonged heavy rainfall are becoming more intense and increasingly unpredictable. Sudden heavy rain in the central region caused rapid flooding, leaving residents with no time to respond. Floodwaters continued to rise, sweeping away trees, houses, and property. Amid the vast expanse of floodwaters, many people were forced to climb onto rooftops, clinging to whatever remained as they waited helplessly for rescue. As floodwaters spread, rooftops became the only safe refuge. Families were completely isolated, with no signal and no escape, enduring heavy rain, cold water, and the long silence as minutes dragged on. Due to flooding, many transmission towers were submerged and lost power, disrupting telecommunications. Residents' phones quickly ran out of battery, making it impossible to contact rescue teams. When all connections were cut off, silence fell over every rooftop amid the floodwaters, and the fear was no longer just the rising water, but the fact that no one knew they needed help. The biggest question now is, how can help reach them in time? With the aim of applying advanced technologies to search and rescue operations and helping to minimize damage caused by natural disasters, the Swarm Robotics and Rescue Systems Laboratory was established, bringing together leading partners and experts in research and technology development. Ho Chi Minh City University of Technology is a leading technical university in Vietnam. Under the Vietnam National University Ho Chi Minh City, with over 65 years of establishment and development, the university excels in high-quality engineering and technology training and applied scientific research. Ho Chi Minh City University of Technology is a cradle for training many engineers, scientists, and experts who have made significant contributions to Vietnam's industry. Igarashi Electric Works Limited is a Japanese industrial enterprise with over 70 years of experience in designing and manufacturing electric motors, especially DC motors. The company owns a global production and sales network, serving the automotive, home appliance, industrial, and medical industries. Igarashi's core foundation is precision motor manufacturing, high reliability, and continuous innovation. IVS is an IT company with Japanese investment, operating for over 23 years in the field of software development and digital transformation. With a team of over 500 employees in Vietnam and Japan, IVS provides customized software, AI, and IoT solutions for businesses. The company is a trusted partner in management systems, production, and operational process digitization. VNX Robotics is a deep tech company specializing in the research and development of robots and advanced control technologies. Based in Vietnam, it has a presence in Japan and an R&D center in India. VNX focuses on core technologies such as motors, drives, actuators, embedded control, and AI for military, industrial, service, and rescue robots. The company collaborates closely with strategic Japanese partners to combine Japanese quality, Vietnamese deployment capabilities, and in-depth research from India, aiming to build an independent ROBOTICS robot ecosystem, free from dependence on China, to serve the global market. From the people who laid the foundation for Lab, we would like to move on to the guiding principles that shape every action and decision we make: our mission, vision, and core values. Mission: applying autonomous robotics and swarm systems to minimize damage, support search and rescue operations, and help alleviate the losses caused by natural disasters to people and society. Vision: by 2030, to become a reputable research and application laboratory in Vietnam in the field of autonomous robotics and swarm systems for disaster prevention and response, to develop highly practical solutions recognized by the professional community and society, and to build an extensive network of deep collaborations with Japan and international partners. Core values: our work is guided by a strong commitment to human-centered innovation, real-world impact, and responsible technological development. We strive to ensure that advanced robotic technologies serve society, strengthen disaster response capabilities, and create lasting positive value through collaboration and sustainability. Humanity: technology is developed to protect human safety, life, and dignity, placing people at the center of all research and applications. Practical impact: research is closely connected to real disaster scenarios, with a strong focus on deployability and practical application in emergency response. Collaboration: we promote close collaboration among universities, research institutes, industry, and government agencies, both domestically and internationally, with a particular emphasis on partnerships with Japan. Responsibility: we uphold a strong sense of scientific and social responsibility throughout the research, testing, and deployment of technology. Sustainability and precision. We develop sustainable, reliable, and precise robotic systems capable of operating effectively in harsh and challenging environments. Next, we will demonstrate how the system operates in real situations. From the Rescue Command Center, a mobile command vehicle was urgently deployed, leaving the safe zone and moving into the storm-affected area. Its mission was to reach the scene as quickly as possible, carrying the full command and coordination system for rescue operations amid severely damaged infrastructure and transportation networks. Inside the command cabin, all systems were fully operational and ready to support coordination efforts. From here, the command team could monitor the entire situation, identify high-risk areas, and prioritize locations requiring urgent assistance, where every decision was made in real time. After a safe access point was identified, the command vehicle selected a suitable location to deploy the rescue boat. The mother vessel was launched directly from the vehicle and advanced into deeply flooded areas, places beyond the reach of conventional rescue vehicles. In parallel with the deployment of the mother vessel into deeply flooded areas, amphibious aircraft were also placed on standby for operations. When telecommunications infrastructure was cut off, the command vehicle quickly became a temporary connectivity hub, deploying 5G and 4G base stations along with lidar systems to maintain communication and control over all waterborne rescue assets, ensuring that every operation remained fully under control. From the mobile command vehicle, amphibious drones were deployed one by one, taking off directly at the scene and carrying beacons into deeply flooded areas to rapidly conduct reconnaissance and mark locations requiring urgent rescue. Inside the control cabin, signals from the amphibious aircraft were continuously transmitted back. On the central display, the real-time positions and trajectories of each amphibious aircraft and the mother vessel were shown, enabling the command team to monitor operations, coordinate assets, and promptly adjust rescue plans as conditions change. With the support of artificial intelligence, the amphibious aircraft automatically analyzed terrain, water levels, and flow directions, selecting optimal locations to deploy beacons and rapidly establishing a connectivity network across the flooded area. Immediately after deployment, the beacons automatically activated and began operating independently. Designed to remain stably afloat, they collected environmental data such as water levels, ambient temperature, and flow direction, while transmitting positioning signals back to the command center. This data helped delineate hazardous areas and supported analytical systems in identifying locations that required priority rescue access. As more beacons were deployed, they automatically linked with one another, forming a beacon network that covered the entire flooded area. This network expanded connectivity and maintained a stable data flow even when telecommunications infrastructure was disrupted. In addition to the amphibious aircraft deployed from the command vehicle, a dedicated drone team was stationed aboard the mother vessel. When required, these drones took off directly from the vessel, serving as the vanguard in search operations. Equipped with infrared cameras, the drone team accessed deeply flooded and complex terrain areas where the mother vessel and other surface vehicles could not operate, rapidly identifying target locations and guiding amphibious boats for precise access, thereby minimizing search time under emergency conditions. Reconnaissance drones are equipped with infrared cameras, enabling them to observe temperature differences across the water surface and surrounding areas. Even under heavy rain, low light conditions, or limited visibility, infrared imaging can detect abnormal heat signatures, helping to pinpoint suspected locations of trapped individuals and providing precise guidance data for rescue teams. All imagery captured by the drone's cameras was transmitted directly to the control center. On the central displays, visual data and thermal maps were updated in real time, with artificial intelligence supporting analysis, delineating suspected areas, and estimating the number of people potentially trapped in each location. This enabled the command team to quickly assess priorities, confirm targets, and make precise decisions in coordinating rescue forces. Once target locations were identified and prioritized, the mother vessel formally began deploying amphibious rescue boats. From the deck, the boats were launched one by one and proceeded directly toward the designated zones, ready to reach victims amid strong currents and complex terrain. Amphibious rescue boats are designed to move flexibly across both water and land. With their multi-terrain adaptability, they enable rescue teams to directly reach victims in areas inaccessible to conventional vehicles. Amphibious rescue boats are operated using artificial intelligence, enabling autonomous navigation along predefined routes without direct control. However, rescue teams always retain full control and are ready to intervene whenever real-world conditions change. Guided by navigation data from the system, the amphibious rescue boats quickly reached areas where people were trapped. Inside the hull, the boats were pre-equipped with drinking water, food supplies, and backup charging devices, helping survivors stabilize their condition and maintain communication while awaiting transport to safe areas. When conditions allow, residents can put on life jackets and hold onto the boat. The amphibious rescue boat then transports those trapped out of the flooded area and toward a safe zone. At the control center, the operational status of each amphibious rescue boat was displayed visually on the central screen. The system continuously monitored the boat's positions, routes, and energy levels, issuing timely alerts when adjustments were required to ensure that all assets operated safely and efficiently. Amphibious rescue boats maintained continuous search operations day and night, without interruption. Even under limited visibility, heavy rain, and complete darkness, the system continued to scan flooded areas sector by sector, ensuring that no one was overlooked, something extremely difficult for human teams to sustain in such harsh conditions. Once trapped individuals were reached, the amphibious rescue boats quickly evacuated them from the danger zone, moving along pre-identified safe corridors. At the transfer point, the mother vessel stood by, serving as a temporary reception and safety hub. Survivors were assisted aboard the larger vessel, where they could rest and receive initial care before being transported onward to a safe area. This demonstrates that rescue assets no longer operate in isolation. From the command vehicle and mother vessel to amphibious boats, drones, and waterborne beacons, all components are connected into a unified, coordinated network, continuously sharing data and supporting one another, enabling rescue operations to be carried out in an integrated manner even under the most extreme conditions.